Okay, we'll continue with the fourth module, that is economic analysis. Economic analysis. If you consider any particular construction company, a lot of works are involved where different types of equipments are being used for carrying out certain jobs. So, if the company wants to purchase an equipment, there will be a lot of suppliers for that particular equipment. So, which of the equipment you need to select? That is the main question for an construction engineer. So, before purchasing, we are going to use many of the economical methods to analyze which is the best alternative. So, object of studying engineering economics is to apply or implement the methods what we are going to study here in selecting a construction equipment. Or also we discussed various types of rate of interest methods that are available. Say for example, you have taken loan with the bank for your education purpose. So by which method you are going to repay that particular loan taken from the bank. So the selection of a particular type depends upon the economic analysis of economic analysis. So we can adopt a suitable method for the repayment also. Similarly, for purchase of equipment, purchase of various articles, etc., we can apply these techniques of engineering economics. So here there are so many methods by means of which we can calculate which alternative is a better and economic one. The first method is called present worth method, future worth method. Third is called annual equivalent method, rate of return method, payback period. So we can select any one of these methods in analysis of any particular problems that we are going to encounter during our construction stages. So let us discuss in depth the various methods. Basic present worth comparison. Now, this method is very commonly used for comparing various alternatives. Present value of future money that is going to be determined. If the future income and costs are known, present value can be determined assuming suitable rate of compound interest. This gives estimate of the price of a property that can be sold or purchased. So, coming to the present worth method, we are going to calculate what may be the present worth of the future income that is expected. Say, you are having a construction company, or you are going to purchase an equipment in the form of, say, bulldozer or a tipper, etc. For that, you are going to get certain profit for every year or every month from that particular property by means of proper usage. So, and also there will be some maintenance and operational costs which are to be incurred by you. So, considering all these things, we knowing the prevailing rate of interest in the bank, that is, you can determine what is its present value. So, if the present value of the thing works out to be more than then we can opt for purchasing of such particular equipment. Here, in comparing the various alternatives by present worth method or any other method, future worth method, etc., calculation or determination of that the time is very important because, say, for example, there are two bulldozers that are available from two different companies. One company may give it for around 10 lakh rupees. Another company may charge 15 lakhs. But you must think why there is change in the price. Say the first one which you are going to get for only 10 lakhs, its age may be only, its life may be only 5 years. But when you are purchasing for 15 lakhs, the the life of that particular equipment may be more than that years, say 20 years like that. So calculation of time period is very important in comparison of the alternatives. So, in the economic analysis, three different cases arises based on time period. The useful life of each alternative equals the analysis period. Say, if the life of both the equipments or number of equipments what we intend to purchase from different companies, if the life is same, then it is easy for us to compare. The alternatives have useful lives different from the period of analysis. So when the time period or life of each of the equipment or alternatives is different, then how to find it? There is an infinite analysis period. So, for example, generally you take any construction of bridge or construction of dam. See how the economical analysis of construction of dam is being calculated. Say, it is the time period for the dam may be taken as 80 to 100 years because the life of the dam is 100 years, and in that particular 100 years, what is the profit that we are going to get is going to be calculated. So, after deducting all the outgoings such as operational and various other maintenance charges, etc., what is the expected profit in 100 years can be calculated. And if we invest some particular amount, we can come to know what amount initially I can invest either by taking loan or investing the money from our side. So, time period becomes one of the very important factor, and it should be very accurately determined. Okay. There are some of the conditions for present worth comparison. Estimate the interest rate that the firm wishes to earn on its investment. Determine the service life of the project. Determine the cash inflows over each service life. Determine the cash outflows over each service period. Estimate the net cash flows, inflows and outflows. If there is single investment proposal, whether a project will be selected or rejected, that can be made accordingly. If the present worth is greater than zero, then we may think of selecting that particular proposal. If the present worth is less than zero, we can reject that particular project. Say, for example, I gave you the construction of a dam. Say, a lot of crores of rupees is to be invested on the dam. Then you calculate what is the life of that particular dam, say around 80 years, and you also collect the data regarding the rate of interest in the locality. Then you calculate what are the operational and maintenance charges to be invested. I also calculate what is the increase in production of agricultural production and various other businesses. So now, if the present worth works out to be greater than zero, then we can select that particular construction of a dam. If its present worth becomes less than zero, then we may have to reject that particular project. A negative present worth means the equivalent worth of inflows is less than the equivalent worth of outflows. Now, if present worth is equal to 0, then it indicates that equivalent worth of inflows is equal to equivalent worth of outflows. So now we will come for the application of this present worth method. Again, here there are two number of approaches by means of which we can apply present worth for comparing the various alternatives. One is called revenue-based present worth. Second is called cost-based present worth. So coming to the revenue-based present worth, see, draw the inflow diagram. P indicates, the downward arrow indicates the expenditures or investment what we are going to do, and R indicates the revenue from that particular investment annually or periodically. And RN indicates return of revenue through scrap value or salvage value. See, already I told you about what is salvage value and what is scrap value. Say, for example, you are going to purchase a bike. So, after, you assume that life of that bike may be 10 years. So, after 10 years, if you save that particular old bike, you are going to get certain amount of money. That particular amount is called as salvage value. If you dismantle various parts of that particular bike and sell it, then whatever amount that you are going to get is called scrap value. So scrap value is an income at the end of M life period, and therefore it is indicated by an arrow in upward direction. So you draw the cash flow diagram. Revenue means how much amount you are going to get at the end of 1 year, 2 years, 3 years, that is indicated by R1, R2, R3, and so on up to Rn. Right. Now, to find the present worth of cash flow from the above diagram for the given rate of interest, the formula is PW present worth is equal to R1 divided by 1 plus I raised to 1 plus R2 divided by 1 plus I raised to 2 plus dash dash to Rn divided by 1 plus I raised to n plus scrap value S divided by 1 plus I raised to n and minus P. Minus P because P is nothing but the initial investment which is going out of your hand to purchase that particular this one. Or if you are referring the table, then PW is given by minus P plus R1 into P by F, comma I and G equal to 1. Similarly, R2, a function of P by F, I, N is equal to 2 years. Similarly, plus dash dash to Rn into P by F, I, N. Now, why this formula I have given in this particular format is, normally when you are comparing the alternatives, you are going to get an interest table. A compound interest table is there, that is going to be supplied. So, if you know the rate of interest, then directly you are going to get the value of R1. R1 it will be known to you, and P by F, I, N is equal to 1. If you compare, you are going to get a constant, multiplication constant. Otherwise, you can use the above formula. So normally, this interest table is going to be supplied to you. So your problem is more simplified and your calculations are going to be reduced. So we can use this particular method for comparison of various alternatives. And coming to the second method in present worth analysis is in a cost-dominated cash flow diagrams, outflows will be assigned with positive sign and the inflows such as profit, venue, salvage, scrap value are assigned with negative sign. So here, the x-axis of this particular cash flow diagram indicates a time period 0, 1, 2, 3, 4, 5, 6, up to n number of years, and P is the initial investment for procurement of any particular article. Then C1, C2, C3, C4, C5, C6, up to Cn indicate the investment, net cost of operation and maintenance at the end of n number of years. And S indicates the scrap value or salvage value, what you are going to get at the end of n number of periods. So you can use this cost-based method also. Here, the present worth is determined by using the expression present worth equals to P plus C1 divided by 1 plus I raised to 1 plus C2 divided by 1 plus I raised to 2 dash dash 2 Cn divided by 1 plus I raised to n minus S by 1 plus I raised to n. So, in this method, by using this particular formula, again I have given you how to use the table. It is the formula, if you are using the table, then the formula is P plus C1 into function of P by F, comma, I and N. Similarly, C2 is a function of P by F, I, N is equal to 2 and so on, minus S into P by F, function of P by F, I and N. So, if you are using the table again, it becomes easy, as I told you. But sometimes if you do not have any table, then use the above formula. C1 will be known to you and rate of interest I will be known to you, C2 will be known to you, I is known to you, N is also known to you, and initial investment P is known to you. So you can determine what is the present worth of that particular method. Whichever present worth is high, that particular alternate can be selected. So, to select maximum profit alternative, the one with maximum present worth is selected. If the decision is to select the alternative with the minimum cost, the alternative with least present worth is selected. See, there are two conditions. One is that this one we will call it as optimum. Optimum may be a negative value in some cases, and it may be a positive value in some cases. See, you need to select to select maximum profit alternative, the one with maximum present worth is selected. If the decision is to be taken to select the alternative with the minimum cost, the alternative with least present worth is to be selected. So now we will take up an example to support this particular derivation. See, present worth problems with usual equal life. Here, useful life of any particular article is same. First, we will solve a problem on this one. I will just read out the problem. Alternative 1, initial purchase cost is equal to 3 lakhs. Annual operating and maintenance cost is equal to 20,000 per year. Expected salvage value at the end of its life period is 1,25,000. Useful life is 5 years. In alternative number 2, initial purchase cost is equal to 2 lakhs. Then annual operational and maintenance cost is 35,000. Expected salvage value at the end of its useful life equal to 70,000, and useful life is again 5 years. So, using present worth method, find out which alternative should be selected if the rate of interest is 10% per year. See, here two alternatives are given. As I told you, you can take the example of a bulldozer. So, a bulldozer may be available for you 3 lakhs, the first alternative. Second alternative, you are going to get the bulldozer for 2 lakhs only. But maintenance cost is higher, that is 35,000 in comparison with 20,000 for alternative 1. So, if you apply present worth method to analyze which of the equipment is most economical or most profitable, then you can very easily apply present worth method for both the alternatives, and you can select a suitable alternative after solving this particular problem. So now draw the cash flow diagram for the alternative number 1. So it is indicated here. We are going to draw the cash flow diagram. Total life is 5 years. Initial investment in the first case is 3 lakhs. And time period is 0 to 5 years. And at the end of 5 years, you are going to get scrap value or salvage value as 1,25,000. So now, in this case, apply this one PW minus P. Minus P because it is an expenditure in the beginning. Minus P minus operational and other costs for the first year minus 20,000 you are investing. 1 minus I raised to n minus 1 divided by 1 plus I raised to n into I. Plus, plus is taken for scrap value because it is an income. Therefore, plus sign is taken. So 1,25,000 1,25,000 scrap value into 1 by I plus 1 plus I raised to n. So substitute in this formula I is equal to 0.1 because 10%, 10 divided by 100 gives you 0.1. Therefore, substitute all the values, and if you simplify, you are going to get the present worth of alternative 1 as equal to minus 2,98,203. Same way, apply cash flow diagram for the second alternative. See here, initial investment is 2 lakhs indicated by the first arrow showing in downward direction. Then number of years is indicated along the x-axis 1, 2, 3, 4, 5 and so on. And an arrow is indicated in upward direction at the end of 5 years, which represents the scrap value or salvage value 70,000. And annually you need to invest on operational and maintenance cost rupees 35,000, that is indicated by the arrows at the end of 1, 2, 3, 4, 5 years. So now applying present worth method, minus 2 lakhs minus 35,000 into 1 plus I raised to n minus 1 divided by I into 1 plus I raised to n plus 70,000 into 1 divided by 1 plus I raised to n. So substitute the values of n and I, you are going to get minus 2,89,215 as the present worth of second alternative. Now compare this one. Both are negative and both are negative. One is 2,98,203 minus value, and this is 2,89,000. So minus value is less in case of second alternative. Therefore, you can go for selecting alternative number 2. Okay, now I will come to the second type of comparison of alternatives, where the life of 2 or 3 number of alternatives are different. Say one life of first alternative may be 5 years, life of second alternative may be 10 years, and life of third alternative may be 15 years. So when there is different life periods for various alternatives, then how to do it? So here, in this particular case, coming to first step, comparison of mutually exclusive alternatives over a time period that is equal to least common multiple of the individual spans is made. See, one is 5 years, another is 10 years, and another is 15 years. So, how to compare this? To have less discrepancy, what we are going to adopt is, we are going to consider the least, least least common multiple, LCM of all the three individual lifespans is going to be determined, and then we are applying present work method, and we are comparing, we are calculating for all the 15 years. Say for example, the equipment whose life is only 5 years, it is analyzed 3 times. 3 times it is analyzed. First 5 years, second 5 years, third 5 years. So here, while analyzing, after the end of 5 number of years, whatever scrap value you get, it is a positive quantity what you are going to get, but you need to invest on purchase of another equipment. So that should be shown. Again, 5 years analysis you can do. Next 5 years, once again, you are going to get scrap value for the second period, and then you will need to invest certain amount as initial investment. Consider that for another 5 years. So like this, all the 3 alternatives will be analyzed for 15 number of years, and you can compare the present worth of all these things, and you can select any one of the alternative. Okay, we'll come to another problem on this particular method. Okay, the material testing laboratory has 2 alternatives for purchasing a compression testing machine, which will be used for determining the compressive strength. The alternatives are from 2 different manufacturing companies. The cash flow details of the alternatives are as follows. See, for alternative number 1, initial purchase cost equal to 10 lakhs, annual operating cost 10,000 per year, expected annual income to be generated from testing of different construction materials equal to 1,75,000 per year. Expected salvage value at the end of its useful life is 2 lakh rupees. And the life of that alternative 1 is 10 years. And we have another alternative, which is alternative number 2. Its initial price equals to 7 lakh rupees, annual operating cost equal to 15,000, expected annual income from testing of different construction materials equal to 1,65,000 annually, expected salvage value at the end of its life period equal to 2,50,000. Useful life of this alternative is given to be 5 years. See, to apply the present work method, since the first alternative lasts for 10 years and second alternative has life of 5 years, you take the least common multiple of these 2. So 10 becomes the least common multiple. So you will need to analyze both the alternatives for 10 number of years. So we will take the first alternative and we will draw the cash flow diagram. So initial investment P is equal to 20 lakh rupees, and you are going to get every year a profit. Every year your income is, at the end of first year you are going to get 1,75,000. At the end of second year also you are going to get 1,75,000. Like that, up to 10 number of years, you are going to get an income of 1,75,000 every year. And annual cost of repair and maintenance is A equal to 10,000 per year. So every year for maintenance and operational cost, you need to invest 10,000 rupees. So this is cash flow diagram. And at the end of 10 years, if you sell that particular equipment, compression testing machine, you are going to get amount of rupees 2 lakhs. 1 zero is missing. Please write one more zero here in your notes. So 2 lakhs is the scrap or salvage value. And rate of interest is indicated at the bottom. I is equal to 10%, which is equal to 10 by 100, that is 0.1. So, equivalent present worth of alternative 1 is as calculated below. Initial investment minus 20 lakhs minus annual repairs, that is 10,000 every year, function of P by A, I and N, plus your income is 1,75,000, which is a function of P by A, I and N, plus 2 lakhs, which is a function of P by F, I and N. So now, see, in the second problem, I have not used that particular formulas. I am using table. So, if you go to the interest table for P by A, for interest rate of 10% and number of years 10, you are going to get this particular value as 6.1446. Plus, for this, you are going to get the interest rate as, from the interest table, a constant of 6.1446. Similarly, for this, you are going to get 0.3855. So if you simplify this above equation, the total value you are going to get it as present worth 90,959 rupees. Same way for alternative 2, draw the cash flow diagram. See, alternative 2 has only life period of 5 number of years. See, at the beginning, you are investing 7 lakh rupees and every year you are investing 15,000 rupees for maintenance and repair, and you are going to get every year a net income of rupees 1,65,000. Right? It is constant up to 5. At the end of 5, here we are imagining that this particular equipment is going to be replaced by another same type of equipment. So, by selling that particular equipment, you get a salvage value of 2,50,000. So, it is shown as income and in upward direction. Then, similarly, at the end of 5 years, the maintenance cost is same, 15,000, but along with that, you need to invest another 7 lakh for purchase of new equipment, new compression testing machine. And this is continued up to 10 number of years. See, this is how we are applying with the least common multiple. That is, for next 5 years, the same thing is going to be assumed. Now, we will go for determining the present worth of this particular second alternative. So, minus 7,000, minus 15,000 function of P by A, I and N, then income 1,65,000 function of P by A, I, N. Similarly, 25,000, 2,50,000 P by F, I and N. Similarly, at the end of you are going to get scrap value, which is a function of, this is initial investment, which is function of P by F, I into N, then 2 lakhs P by F, I, N function. So, these, if you go to the table, interest tables, you are going to get the multiplying constants as 6.1446, 16500, 6.1446, similarly 0.3855, 0.3855, 0.3855. So here, from this, the present value works out to be 38,660 rupees. So now you can think, since equivalent present worth of alternative 1 is more than equivalent present worth of alternative 2, the alternative 1 is preferred. So the present worth of first alternative is better than second alternative. Therefore, you can prefer the first alternative. We will take up the next problem. A small scale company wants to buy a milling machine. There are 3 machines in view from 3 different manufacturers. The initial investments, annual revenues, salvage values, and lives of the machines are given in table. Determine the present worth of all the machines and best alternative. Rate of compound interest is equal to 14%. See, here in this case, a milling machine is to be purchased by a company. There are 3 manufacturers. One manufacturer gives M1 type of machine. Its initial investment P is equal to 48,500. Annual revenue from that annual income 15,000 per year. Salvage value at the end of 7 years is 5,000 rupees. Life of the equipment 7 years. Then second equipment, it costs 52,000 and annual income is 17,000 per year. Salvage value is 7,200. Its life is also 7 number of years. Now third is 62,500, 20,000 is annual revenue, salvage value 9,300, and its life is also 7 number of years. So consider first alternative, indicate or draw the cash flow diagram as shown in the figure. P is initial investment, therefore it is shown in downward direction, and net incomes at the end of each year, they are shown in upward direction, that is 15,000 every year up to 7 number of years. At the end of 7 number of years, you are going to get a scrap value of 5,000 rupees. Right. So now apply PW for salvage value plus PW for annual revenue minus PW for initial investment. So use the formula S into 1 divided by 1 plus I raised to n plus A into 1 plus I raised to n minus 1 divided by I into 1 plus I raised to n minus P. So substitute the values of n and I in the above formula. You are going to get the present worth of first alternative as rupees 17,822.5. Similarly, for the second alternative, draw the cash flow diagram. P is equal to 52,000, annual income 17,000 every year up to 7 number of years, and scrap value is indicated in upward direction, that is 7,200 rupees, and 14% is the compound rate of interest. So PW for salvage 1 divided by 1 plus I raised to n plus A into 1 plus I raised to n minus 1 divided by I into 1 plus I raised to n whole thing minus P. So substituting the values of I, A, S and N, we are going to get get the present worth of second alternative as 23,778 rupees. First was 17,822. Similarly, determine the present worth of machine number 3. So here, once again, substitute in the formula all the values. You are going to get 26,992.56. Since the present worth of machine 3 is the highest, select alternative 3. So this is how we can apply present worth method to decide selection of various alternatives. See, this particular technique of present worth method, you can apply in your company. Say if you want to become an contractor by means of undertaking some contract work from government or some private bodies, then you may have to possess certain equipments, say earth movers, or it may be tippers, or it may be tractor, or it may be JCB, like that. You may have to purchase various alternatives. So compare all these things. Similarly, this particular technique can also be applied for purchase of materials. Say from 2 or 3 number of quarries, you have availability of aggregates. The quality of aggregates is same, but the rates may be different. Again, transportation charges may be different. One quarry may be 15 kilometers away from your site. Another quarry may be 50 kilometers away from your site. Another quarry may be 20 kilometers away from your site. So you calculate the transportation charges for what amount per cubic meter they are going to provide you the aggregates. Then work out various other things, rent towards transportation, etc. And you can come to know if you purchase from which quarry, you are going to get it for least amount. That is, you can compare all the 3 alternatives by means of applying this present worth method.